Step 1 in the excitation-contraction coupling is the ACH from the motor neuron being released in the synaptic cleft and binding to the receptors on the muscle. This depolarizes the membrane, and then this depolarization is propagated down the T-tubule, which leads outside of the muscle fiber and into the sarcoplasmic reticulum. This in turn depolarizes the SR, inducing calcium ions to be released, and these calcium ions bind to the actin filaments, exposing the active sites. Specifically, the calcium ions attach to troponin, which is attached to tropomyosin, allowing the tropomyosin to be released from the actin and exposing the active sites. After the active site is exposed, myosin heads can now connect to these newly exposed active sites, which the myosin heads use their stored energy to pivot these actin strands, pulling the actin strands and therefore shortening the muscle. After this, new ATP binds to the myosin head, and therefore is allowing the myosin head to release from the active site, and this ATP is broken down and its energy is stored, and this energy is used to reset the myosin head. And as long as active sites are open and the nervous input, which causes the calcium to be released and ATP is available, these steps will continue accordingly.
A sarcomere is the most basic unit of a muscle, and it's the portion that actually moves when a muscle contracts. A sarcomere consists of repeating sections separated by two Z-lines. Within a sarcomere, there are thin filaments called actin and thick filaments called myosin. When a muscle contracts, this actin slides over the myosin, pulling the Z-line together and shortening the sarcomere. It is that sliding action that causes the entire muscle to contract, and if all the sarcomeres within a muscle fiber do this alternatively, then it will lead to movement.